Perfect. Well, then welcome everyone. Welcome to another webinar hosted by Chemical Engineering Life, titled Computational Process Optimization. We welcome our guest speaker, Henry Susilo, who is himself a chemical engineer, and he will work you through a workshop solving two case studies about process optimization. Moving on to the next slide, Henry. The agenda for the presentation is that the first 5 minutes that is reserved for welcome. Then I'll walk you through the organization, Chemical Engineering Life. Then the rest of the time is allotted to Henry, and he will walk you through two different case studies and give you a little bit introduction to optimization and all the other theoretical aspects, but I'll leave that to Henry. In the end, there will be 20 minutes for questions and answer. You all are welcome to ask any question that you guys may have, any doubts that you may have about the presentation or anything about optimization. Feel free to ask them to Henry. Then in the end, the last 10 minutes, they are simply reserved for the closing remarks. Well, then very first thing, welcome to our speaker, Mr. Henry Susilo. He is the undergraduate chemical engineering student currently studying at the Bandung Institute of Technology. And he is one of the most accomplished students they have in their area. He's currently interested in working in process modeling, simulation, and optimization. He has worked as a process assistant at an engineering consulting company as a part-time, of course, and he also makes different YouTube videos and has a YouTube channel. So please do remember to visit and subscribe and like to his channel after the webinar as well. Now, introducing myself. Well, my name is Humzaa, and I am the founder of Chemical Engineering Life. I myself am a chemical engineer. I graduated from the Technical University of Denmark back in 2020. Since then, I have been working as a quality engineer at a pharma company called Pharma in Denmark. My main focus in my study has been on process design, process engineering, and which led me to having two different publications which focus on sustainability and biorefinery. So coming down to the organization, Chemical Engineering Life, we are aimed at connecting different chemical engineers from around the globe. A little bit about who we are and where we come from. So the organization itself was founded back in 2021, February. In the beginning, I started off by interviewing different chemical engineers, asking different chemical engineers what they do for a living, where they work, what they do, simply to get an insight for different graduates about what sort of life awaits them once they walk out the gates of the university. Because in my experience, there tends to be a lot of ambiguity about what chemical engineers do. And through that, we wanted to remove the gap between the university and the graduates and the students, graduates and the industry. Then in August 2021, that is when we launched our website. And from the website in September 2021, we launched our very first mentorship program. The mentorship program is something I'll dig a bit deeper in the next slide. But in the March, that is when we launched our webinar. And this is our third webinar that is being hosted with a guest speaker. And the coming month in May 2022, that is when we are planning the launch of our monthly chemical engineering magazine. So if you are interested in having a monthly subscription, it is actually a free magazine. So feel free to subscribe, go to our website, become a member, and then you will get a chance to subscribe to it, and you will get it an online version at the end of every month. And this is not the end. We like to see this as simply the beginning, and hopefully there are a lot more exciting initiatives on the way. So like I said, we are an organization that is aimed at minimizing the gap between university and the industry, allowing different students or graduates to know what to expect once they graduate. And we do that by creating an online community where every single person you meet is a chemical engineer, either working in the industry or about to become a full-time chemical engineer. Through that community, we have been working on our mentorship program. The mentorship program is aimed at connecting different industrial engineers with different graduates so that the graduates can ask directly the professional who has been in their shoes and have walked the same path that they're walking right now. We have this webinar area, and the webinar is a direct communication or direct connection with the guest speaker who is an experienced person with multiple students, graduates, or other persons that would like to take away a little bit from their knowledge. And finally, the interviews that I had mentioned, and the interviews are also just simply talks and in question and answer with different industrial professionals who might answer a few questions that you have not found the answers to yet. So coming to our mentorship program, the mentorship program is a biannual program that is conducted for 5 months. The first session goes from February to June, and the second one goes from August to December. So currently we are running the first session of our program. And currently we have around 35 mentees. The mentees are people that are either young graduates or still in school for master students or also final year bachelor students. We have 42 mentors. The mentors are all industrial engineers. So they're all working in their respective fields as either in research area or industrial area. And all of the mentees and mentors, they have joined us from 16 different countries. Now the mentorship program is not limited to one country, to one school or one university. It's a global program. So majority of our students have joined us from Denmark, India, Pakistan, South Africa. We have people from US, Canada, Indonesia. So it is all over the globe. And that is the beauty of the program, because if you sign up, you can end up becoming connected with someone that is working in the US or working in Germany or working in India. In that way, it helps you broaden your horizon and broaden your understanding of how chemical engineering is applicable in different environments, in different countries, and also helps you really get out of the paradigm that you may have been living with in your country. So if you're interested in the mentorship program, feel free to go to our website and you can sign up already now. But of course, the signing up for the current session is no longer possible because there's only 2 months left. So I highly suggest that you sign up for our very next session that will begin in August, and for which we have already started the planning. So feel free to visit our website and do sign up for the program. And on our website, we also have a membership area. It's a free membership. The idea of the membership is so that we can create a feeling of the community. And by becoming a member, you will be the first person to know when a new initiative goes live. You will be the first one to know about our upcoming webinars, and you will be the first one to know about our interviews. So do go to our website and do become a free member. And like I said, it's a free membership, but you get a lot out of it. So looking forward to it. I hope many of you will go in and join us as a member. Thank you. And that is actually all from my side. Then Henry, you can take it away.
Okay. Thank you, Humzaa. Good evening from Indonesia to all of you. It's been a really big honor for me to be the speaker of this workshop, because I think that I am the first undergraduate student that do this webinar session. Yeah, so thank you very much for Chemical Engineering Life. And I think my mentor come today, Mr. Wilfredo. Hello. He will do the webinar tomorrow. Yeah, thank you very much for your time. Yeah, so today I will talk about something modern in the chemical engineering world. It is called the computational process optimization, because in my opinion, right now in the industry 4.0 or 5.0, computational is a really must-have skill. And as a chemical engineer, even though we are working with the real physical process plant, but the computational skill is still needed for us. Okay, so this is a little bit about myself. My name is Henry Susilo. You can call me Henry. I'm from Indonesia. I ever be president in ITB. If you know IT is the American Institute of Chemical Engineers. My passion is in the simulation and modeling and optimization. I'm right now get my certification in expert user in Aspen HYSYS and ongoing with the Aspen Plus. And my recent projects, I ever do projects in the oil and gas industries, chemical industries, wastewater treatment, yeah, and so on. So right now I'm in my 6th semester chemical engineering degree at Bandung Institute of Technology in Indonesia. Okay, so yeah, I have a YouTube channel, and this is not my first time to be the speaker in the webinar. I have done some workshop. This one is about Aspen Energy Analyzer. This one is about the wastewater treatment design, and this one is about process safety design. So if you have organization, or you have your company needs someone to have a training, you can feel free to contact me if you feel that I can do that. Okay, about optimization, so I will start with my story. I think 6 months ago, I have projects in the dimethyl ether or DME synthesis simulation. So my task is not only doing the process simulation in the Unisim design, yeah, by Honeywell, but I have a task to optimize the process. And what is interesting in this project, because in a plan-wide process, we have many variables, we have many uh, parameters that we need to be optimized. So it is a multi-variable optimization. So what I do here is doing a multi-variable optimization. I use Python, and I use the neural network. Yeah, I use machine learning to solve this problem, to build a model, and using the algorithm to optimize the process. Yeah, this is a really interesting problem, because from this projects I know that we really need optimization, and it is a really important one in the chemical engineering, as a chemical engineering student, or if you have done to the industry. Okay, so for this presentation, I use these 3 main books. The first one is a really old book, Optimization of Chemical Process by Himmelblau. This book is a really good starting point for you guys that want to study optimization. And the next one is the Optimization for Chemical and Biochemical Engineering. This one also a good book, recent published. And the third one is more specific to the GAMS. I will use the GAMS software today. So this book tells about nonlinear optimization, and I will tell you what is that later. Okay, so this is the table of contents for today. I will start from a little bit about the theory, so everybody can come in, even though you haven't studied yet about optimization. And today I will do 2 case studies with 3 softwares. For the scope of the workshop, I will have a less theoretical explanation. So if you want to have more one, you can search by yourself in the internet. And I will do only a single variable optimization, because multivariable optimization it is quite a complex subject, and yeah, it needs more time for that. And then the next one, I will do the optimization in the steady state mode, not in the dynamic mode. And lastly, optimization will only be done to the system that have a simple model. So I can say that we will not use any process simulation software today. So yeah, this model have a really simple equation. Okay, I will start from the background. So optimization, we can say that as finding values of decision of variables that provide maximum or minimum, or of one or more desired objectives. And in a more scientific language, we can say that as minimize or maximize a function, if it can be called fx with respect to x. X is the free variable that we will optimize, and subject to hx equals to 0. This is just an example of the constraints. Okay, so optimization is really applicable in our daily life. For example, this picture shows a simple optimization in our daily life. There is a truck that want to go, for instance, to the Y house. So he need to decide what road is the best to, so he can come to this house fast enough, yeah, to deliver the material. So this technology also been used by Google Maps. If we use Google Maps to travel, the machine will recommend the best route so we can arrive earlier. Okay, so why we need optimization? Because a decision based on optimization and decision based on intuition. As an engineers, we have intuition on the process variables, on the equipment design, but intuition is can be wrong. Yeah, intuition is not a really precise one. So if we use the computational optimization, it will be more precise. It will eliminate errors. Yeah, so I think optimization is a really important one. And engineer, we always work for a continuous improvement. For instance, if we are working with the energy recovery, in this month we will recover 50% the energy, the next month we will recover 80%. Yeah, we will always do an improvement, and by optimization we always can do an improvement. And lastly, the all engineering designs are optimizations. Yeah, for example, if we are talking about the vessel, it has some geometrical variables like the diameter, the length, the seam to seam length, and yeah, so on. So I think that all engineering designs are optimization. So this is a really interesting one. Optimization is unreliable. Somebody said that a lot of uncertainties exist in the model. So maybe I want to ask you guys, what will be your answer if you meet these guys that says that optimization is unreliable? Because if we build models, we have a lot of assumption, so we cannot use the result of optimization. Do you guys have any idea to answer this kind of guys? You can put it in the chat box, or you can directly talk. What if you what if somebody said this to you? Oh, you cannot trust optimization because the model is contains a lot of uncertainties. Do you have any ideas? Or you maybe agree with this person? Okay, so if you are still thinking, in my opinion, this statement is not wrong. Yeah, it is true that optimization contains the unreliable source of data, unreliable model, but we as an engineers, we have intuition. Yeah, you're correct, Salmani. That what makes it is exciting. So it is correct that optimization, we cannot fully 100% trust the result of optimization. I need to tell you now that don't ever trust 100%. We should be skeptical with the results. Don't always take it. Okay, then come to your boss. Sir, I have optimized the process. This is the variables. Don't do that. Yeah, but we need to keep doing the research. It is doing the validation if our model is the right one. Yeah, so even though optimization cannot be 100% trusted, but we can still get insights from the optimization. Okay. Yeah, optimization in chemical engineering. So the typical problem in the chemical process design or plant operation may have many or possibly an infinite number of solutions. So from what I showed to you, the DME synthesis process, yeah, I will come back to the slide here. Yeah, if you see from the process simulation, it contains many unit operations and many variables to be optimized. And so we have many solutions to the simulation. Okay, I will come back here. Yeah, so as a chemical engineer, there are 3 requirements that I have been summarized so we can have a good optimization. The first one, as I say, we cannot trust the result 100%. We have the analysis, we have to be skeptical with the result, and also we have to get insight from what the appropriate performance objective. So sometimes companies have their own guidelines. We can use that as our reference. And last, we can use the past experience as our engineering judgment, because sometimes our past experience can be a good teacher for us, so we can judge whether the result of the optimization is good or not. Okay, so in chemical engineering, I have found some simple example of the optimization. The first one is the vessel insulation. We could see here, if we have a really thick insulation, so it will increase the cost of insulation. But in the good side, we have a low cost of lost energy. But if we use the minimum thickness of insulation, we will have a less cost of insulation, but we will have a more cost of energy. So this is one of the pretty simple example in chemical engineering. So we should be decide where is the optimum point. When we use the total cost curve, we can see that there's the minimum point here, and we can use that as the minimum thickness that will give the best minimum cost. The next one is the boiler operation optimization. When we are dealing with the Rankine cycle, we use boiler. If we increase the air to fuel ratio, and it will decrease the emission of NOx, and also we will prevent the CO, carbon monoxide, in the flue gas, but it also contains some disadvantage if we use the high air to fuel ratio. The last one is the reflux ratio. When you're taking the separation class, we know that if we have a high reflux ratio, that we will have a lot cost of heat from the reboiler or from the condenser. So the operational variables will be higher. But if we use lower reflux ratio, we will decrease the cost of heat, but we need a higher column, which means we have a more capital expenditure. So we should optimize also in the reflux ratio. What is the best reflux ratio that will result in the less cost? Okay, so that is 3 examples in chemical engineering. I want to tell you guys that how optimization is really important in chemical engineering, because there are a lot of cases that requires optimization. Okay. Thank you for your response in the chat. I will read it later. So before we are talking about the softwares, I will go to the theory for a bit. Yeah, I already explained this as the first one. Optimization is easier to be executed in the continuous function. So in some case, we have the discontinuous function. For example, is like the steam grade, or we have the coal grade, like lignite, anthracite, subbituminous. That is a discontinuous function, but it is easier to be executed in the continuous function. And there are 3 basic elements in the optimization problems. The first one is the minimize or maximize. It can be minimize the energy consumption, maximize the profit, and other else. The next one is the with respect to. This is the free variables that we will optimize. So it can be a temperature, pressure, flow, composition. It can be a design variables such as length, diameter, and other else. And the last one is the constraints. We can classify it into the equality constraint. It can be a mass or heat balance. If mass or heat balance, we cannot use the inequality constraints. Should be balanced, is equal to be it must be equal to a value. The equilibrium relation also use the equality constraint, and while the inequality constraint, it is like the environmental quality regulation. Example is the BOD of the wastewater treatment. It should be less than particular value. The maximum pressure drop in an equipment, the maximum allowable working pressure of the equipment, it can be used by the inequality constraint. Yeah, so these are the 3 basic components in the optimization problem. Next, so one of the most important concept is about the model function. In the case of unconstrained minimization or maximization of the objective function, we have two functions. The first one is unimodal. You can see that unimodal function only have one optimum, only have one optimum variables. But in the multimodal function, it will be harder to be optimized because it contains many global or local optimum values. So to know whether our function is unimodal or multimodal function, we can learn about the convexity. So I think I will close the full slide because I need to do some, wait a minute. Okay. I hope that you can still see my screen in the PowerPoint. So how we can know that our function is convex or concave? Mathematically, you can see this one, but I will explain it in the more easy way. So if you have a curve, you can generate this curve from sensitivity analysis. So if you take, for example, an arbitrary line, if your line is upper than your function, then you can set that as a convex. You can take any line arbitrary. For example, if I, wait a minute, my PowerPoint is not responding. If you try to use another line, you will find the same trend that the arbitrary line will always be in the upper side of the curve. For example, like this, or you can like this. Any arbitrary line will be always upper. In the opposite, if you have a concave function, if you draw an arbitrary line, your line will be always lower than your function. So if you found this kind of curve when you're doing the sensitivity analysis, you will always have a one optimum point, no matter what. You always have a one global or maximum or minimum. But if you found this kind of curve, wait a minute, like this. If you take a line in here, the line will be upper. But if you take the line here, your line will be lower. So when an arbitrary line is not located in one absolute position relative to the function is called non-convex function. So this is quite complex to optimize the non-convex function because the global maximum or minimum is hardly confirmed. So I have the 3D model here. You can see, for example, if we are located in this point, the machine can recognize this as the optimum point, but they don't know that there are the more higher point here. So this is why the non-convex functions is harder to be optimized, because the machine can stop to run in here, in here, in here, and they cannot recognize if there are more higher value in the other location of variables. So that is a little bit about convexity. This is the one of the important concept of optimization. Okay, so about the optimization method, I will not explain the algorithm one by one, but only introduction. The first one, we have the function value based method or direct method. So when you use the direct method, you will have a trial points, and the trial points will substitute to the function. We have the initial value x0, and we will calculate the value of the function, and we will do the second guess x1. So the value of the second guess will be higher or lower than the first, and we will stop when the value of the n value of the n function will be less than the epsilon. Epsilon is the tolerance. So the example of this method is the bisection method. When you have an initial value, and the function will always section to a smaller range, for example, A and B, then they will have a the smaller section, for example, here and here, until they found the optimum value. And then the golden search method, this is also can be categorized as the direct method. But the most favorite method is the indirect method or derivative based method. From the name, we can conclude that this method uses the derivative of each iteration stage. The example is the Newton method. This is a really popular method if you use the process simulation, Aspen HYSYS or anything. Newton method is used also for optimization, besides SQP and others. Also, the second method also use the derivative one. But in the second method, it is more complex because you have 3 points of three points of gas. Okay, so indirect method is actually more efficient than the direct method. Direct method on all tests, and even though it is more efficient, the derivative can be facing some serious problem. For example, if we use Newton method in a saddle point containing function. So if you found this function, you will have the value of something divided by 0, and you know that the answer of something divided by 0 is, we cannot have the answer on that. So we should be careful by with using the indirect method. And then no method can find a global optimum if multiple local solution exist. We have learned about the multimodal, using the non-convex function. There are no methods that can guarantee that the result is the local or global optimum. Okay, so I will continue to this. Okay, the optimization, we can divide it into two categories. The first one is the unconstrained and the constrained one. And the easier, of course, the unconstrained, because we can have a wider option of the free variables. If the one variable, we can use Newton, second bracketing section. Multivariable, we can use simplex. This one also a really popular method in the multivariable optimization. If we have a constraint, maybe you ever heard about linear programming. Linear programming, this is a quite popular one. SQP, if you are working with the process simulation optimization, you will know this method. SQP, GRG is used by the Microsoft Excel. Later I will show it to you. Okay, I will come to the software. We can use some software to you do the optimization. Blingo, Matlab, Minitab. Minitab is not only used for the statistical problem, but also can be used as optimization. And then the next one is GAMS. GAMS is a software that only can do optimization, nothing else than the optimization. The last one is the Microsoft Excel. And today I will do 3 softwares: Matlab, GAMS, and Microsoft Excel. I am pretty sure that everyone have learned Matlab in your university. Microsoft Excel, I know that you're maybe better than me. So I think that GAMS is a quite rare to be studied in the university. So I will a little bit go deeper on GAMS. So GAMS is the general algebraic modeling system. This is a programming language base that provides a flexible framework for formulating and solving a linear, nonlinear, and mixed integer optimization problem. So I can say that GAMS is a really powerful software for optimization, because you can do optimization on the linear, nonlinear. You can do it on a continuous function or discontinuous function. So this is really powerful software for optimization. Okay, so GAMS, we can say that as a language, because we will put some syntax in the software. As like in Matlab, we will use semicolon as the last statement, and then we can use any asterisk if we want to put some comments. Okay, So this is the basic components of a GAM model. It will look like this. If you are using the Flex PDE, the structure of the coding is quite a little bit similar with the Flex PDE. You can see that some titles as a header, and the other one, the rest will be the syntax that we will use to optimize. Yeah. So I think it is enough for the introduction. For the theory, we will move to the case study. So the first one, I will do the unconstrained optimization. I will use the pipe insulation thickness optimization. So you are asked to design insulation for a large pipe that contains hot liquid. The insulation is needed to reduce the heat loss from the pipe, and the rate of the heat loss can be approximated by this formula. And the cost of insulation can be modeled by this following equation. So we have a fixed cost and the variable cost that will be depend on the thickness of insulation. So actually, we can consider this as a multivariable optimization if we look this problem as a separate one. So the first function is the heat loss function that we will be minimize the heat loss, and the second function is the cost of insulation. We also want this to be minimized, and to make our problem easier, we will merge this function become a one function by this statement that 1 kilojoule per hour of energy saving is equivalent with $2. So this one, this function will be converted to a money. Yeah, so money and money, we have one variable, and we will have a one variable optimization. Okay, so I think I will start to share my screen, all of my screen, so we can start the problem. You can open this Excel. I think Humzaa already sent it by email. We will do it first at the Microsoft Excel. Okay. I will prepare myself first. The first one is the parameters. We have the area. We can enter the value, the delta T, the K, or the coefficient of conduction, the coefficient of convection, and the income is $2 per 1 kilojoule per hour of energy saving. Okay, and then the next one is the input variables. So the X, or the thickness of insulation, is what we want to optimize. So we can put this as an arbitrary value. For example, it's 0.03. Don't worry, this value will be changed when we optimize. Next, the profit function. So here we have two functions, the income and the expenditure from the insulation cost. So the profit will be income minus the expenditure. The income, we can do that as this one, GA, the amount of the amount of heat that we save. Yeah. Sorry. A delta T per. Okay, you can do this problem with me together. X per K plus 1 per AC. Okay, so this is the rate of heat loss. So if we have a minimum heat loss, we will have a more energy saving. Okay. So this is the heat loss. So what is our heat available? We can do this one, GA times G5, the area, and 6. Yeah, we can do a simple MCP delta T. Yeah, uh, the heat, yeah, the heat from the system minus the heat loss. We will have the function of heat save. Okay, the heat save we will times with the income. Yeah, every 1 kilojoule per hour of energy saved, we will get $2, and then we will subtract it with the cost function to get the profit. So 30,000 plus 9,000 times the thickness. So we have now the objective function result, and we will do optimization. So you can do in data solver. We will optimize the profit. Of course, we want to maximum the profit by changing the cell of this one. Right now, we don't have any constraint, I guess. Or maybe the constraint, we can change this. Wait a minute. Delete the constraint. Sorry. Oh, sorry. The objective. The objective is this one. Okay. Of course, insulation cannot be negative. So, yeah, we will should set this larger than 0. Okay, and we can. Okay. So you can see that we have the value now 0.07701 with the optimized profit at $13,000. Okay, so it is a really simple one. I will continue because my time is not much to the Matlab, and I will open my file. Wait a minute. Insulation optimization. Okay. Yeah, you can see here. I will use the admin search routine. The function, it is the same, yeah, with the Excel, the objective function, and then we do this one as an early guess. By the way, don't worry about the file. I will also send the Matlab file and any file that used in the workshop in the email, and I will use here an admin search, yeah, where we can just run the problem. Yeah, okay, see, we will get the optimum diameter insulation. Same result with the Microsoft Excel. Okay, the same result. We use the admin search, and actually we can do this as well. The sensitivity analysis. Wait a minute. So sensitivity analysis. So I will vary the insulation thickness, and I will have the plot. Okay, I will run this one. This is another things that you can do. Yeah, you can see here. This is the graph. You can see this as a unimodal because we only have one optimal value. The value of that result in optimization is in the 0.07, so it will be around here. Yeah. By the way, maybe you can you ask why this one is negative, because if we use the admin search optimization here, admin search, so we will always search for the minimum one. But in this case, we use the optimal value as the maximum value. So here, if you notice, I use the negative value in the objective function. So in other words, I say this is as the F max search. Yeah, because I use the negative one here. So I will search the maximum value of the optimization. The third method that you can use here in Matlab is you use the optimization apps. It is located here. I already have a file here. You can just copy the function later, yeah, to the objective function, this one, and you open the optimization here. Okay, wait for a minute. Okay, you will open this page. Here we will use the fmin search. The objective function, we will use the title here at phone. And for the starting point, I can use any value. For example, is 0.03, and we will start the optimization. Okay, we can see here the iteration stop at 15 iteration, and we can see the final value, the same value, 0.077. So it is a proof that our simulation or our optimization have a consistent result. The last one with GAMS. Okay, I will go through with my files here. Wait a minute. Okay. It's the insulation thickness. So here you can see the first one, I define the parameters, the area of the heat exchanger, sorry, the pipe, the area, the difference of the temperature, the conduction, the convection, and income. And then I define the positive variable or thickness. It always be positive one. And then the free variables as the profit function. This statement is the early guess of the free variables. I guess it early as 1. And then in the equations, we will define the objective function. You can see here, it is the same with what we define in the Microsoft Excel or in the Matlab. Yeah, we can see that the objective function is P equals to, yeah, this one is equals to the objective function. Okay, the next one is model, this case study. Then solve this by using NLP. So what is NLP? NLP is the non-linear programming, because I have a non-linear equations. I use NLP here by maximizing. Yeah, this can be changed by minimizing or maximizing. P is our profit function or our objective function. And lastly, I will display the result. So it is quite simple structure of programming here. We define the parameters, the variables, the equations, and then the optimization, and lastly, the display. Okay, I will run the simulation here. You can run games here. Okay. Okay. Yeah. So it is done. It is done. Yeah. We can see the result. It has the same result, 0.077, with the same value of the profit. The optimized profit is $13,000. Yeah, it is the same. So we can see from by using 3 different software, we will have the same result. Okay. Sorry that I cannot look for the comments now. Okay. I already put the step-by-step here. If you want to do it by yourself later after the session. So yeah, I hope you can do this also. Okay, 15 minutes. I will finish the case study, the second case study in 15 minutes. Okay, the second one is actually more complex than the first one. Here I have a multi-product plan. We have the EFG as our product that reacts from the A, B, and C. So you can read this by your own later. So in this problem, I will optimize the flow of A, B, and C so the plan can gain a maximum profit. Okay, so here my problem is if I put too much A, B, and C, of course I will result in a more higher product. But don't forget that we have costs here for the raw material, and we have the availability for each raw material. So example A here, we only can supply 40,000 kilogram per day. We cannot supply more than that. So this problem is a multi product plan. We have multi constraints here, the availability, and we have the heat and mass balance, or sorry, only mass balance that we should define as the constraints. So here I have done it to you, the construct the mass balance of the system, also the stoichiometry or the reaction. Here I have list down the reactions. So from this mass balance and the reactions, we can get the objective functions. The constraint of material availability, you can see that the variable of x11, x12, and x7, it should be less than the maximum availability, but it should be larger than 0. Okay, so this is the objective function from the raw material cost and the processing cost and the income. So for the profit function, it is the income minus the raw material cost minus the processing cost. Yeah, it is more complex from the previous one. Yeah, but I hope that you can bear with me. Okay, so for the second one, wait a minute, I will open the file. Wait a minute. Okay. Case study workshop, case studies. Okay, I show first the Matlab. Yeah, here, multi-product optimization. So for this problem, I use the fmin_con. Where is it? The fmin_con. Yeah, the linproc. Yeah, linproc is linear programming. So if you see from our problem, yeah, here we only have a linear model. Yeah, we have a linear model. So here I use the linear programming to solve the problem. Okay. It is different from the previous one because the previous one is non-linear, but this one we have a linear one with the objective functions here. Yeah, the objective function, and this is the inequalities and equalities. What is the inequalities? The inequalities will be the material availability, and the equalities will be the mass balance. Yeah, so we have two domains of constraints. It is the inequalities that comes from the material availability, and the equalities from the mass balance. Okay, the next one is the objective functions. We already defined that in the third step. Okay, and yeah, you can see the syntax here is yeah, it is same like the previous one. Okay, so I will run the simulation here. Okay, see, you can see the optimum solution found. Yeah, so the x11 here, the A should be 40,000 kilogram per day. The x12 is the B1, it should be 13,750 kilogram per day, and so on. So we could see the variable has been optimized. Okay, so that is for the Matlab one. We could see also the x8. X8 is the E1 is 0. But if you have another constant, for example, that, oh, sorry, but you should have the E product. So you can adjust this one. You can add another constraints that, for example, the E product should be more than 20,000 kilogram per day. For example, you should set a value, so it will be not set as 0. But for now, because we it is okay if one of the product is 0, so we will let it be. Okay, I will move to the Microsoft Excel here. Okay, wait a minute. Yeah, so I will do the same one. I will guess the input variables here. and the constraints. This is the equality constraints from the mass balance and the inequality constraints from the material availability. And this is the objective function that we will optimize. Okay, so if we do the optimization here, yeah, you see here, I will change all the variables in the input variables by the objective function of the L for the constraint. I will choose every cell here as a constraint. Okay, maybe I will change this one so you can see how the solver can optimize. Like that. Okay, now I'll change. We will done the optimization. Okay, so wait a minute. Why? Okay, yeah. You see, when I set an arbitrary value to the Microsoft Excel and I done the solver here, the max, yeah, the result will be the same as we do in the Matlab. Okay, so in my opinion, it is more simpler to do this at Microsoft Excel than in the Matlab. Yeah, you can choose what software will be the fits for you. Okay, and the last one in the GAMS, I will open the multi-product plan optimization file here. The GAMS also really simple. If we compare it to the Matlab, the same structure, we define the parameters. The parameter I define is the maximum value of each raw material here. And then the positive variable, of course, we will not have the negative mass flow rate. So I will use the mass flow rate as the positive variables here. And you will always set the profit function or the objective function as a free variables. This is a must, because if you choose to set the free variables, the objective function as the positive variables, the simulation will result in error. The next one is the early guess. Yeah, I always set an early guess for each problem here. Okay, and then the equations beside the objective functions, we also should define the constraint. Here in AQ1 until AQ3 is the equality constraint, but in the inequality, it is the inequality constraint. You can see from the symbol here, I use E. E stands for equal. This is L. L stands for less than or equal than, and or equal to. Okay, so this is the inequality constraint, and this is the equality constraint functions, the objective functions here, and the rest of them is still the same. Yeah, we will model case study by maximizing the P. And you can see here, I use the LP or the linear programming because we have a linear equation. So it is not mandatory to use NLP or non-linear programming. Okay, so it is more simple to do it at Microsoft Excel or in the GAMS for me. Rather, in the Matlab, you can see here, my syntax is more complex. Yeah, but you can define it very easily in GAMS. I will run the problem here. Okay. This one, yeah, you can see this is the iteration done by GAMS, and the final value you can see at below. Where is it? This one. Okay, so you can see that the result will stay the same. Yeah, the result of the objective is 705. It is same with the Microsoft Excel 705. Yeah, so we result the same one. We can see that the variable x8, it comes to a 0 value. Yeah, it is consistent with the result of the Matlab, also with the Microsoft Excel. Okay, so yeah, we can see that in the two case studies, it will result in the same value if we correctly input the parameters, the equations. Yeah. So you can choose which software suits the best. Okay. So maybe what time's left now? 10 minutes. Okay. So we have done the two optimization problems here. A really different problem. The first one, we don't have constraint, but we have a non-linear model. But in the second one, because we only have a simple mass balance, so we will have the linear model. Linear model will be more easier to be solved in GAMS, in Matlab, and other stuff. Okay, so before closing the presentation, um, maybe it is quite a rush for me to present about optimization, because for me optimization is a quite challenging subject. It is need a lot of practice. Also, yeah, it is a really technical subject. So I will open the question and answer if you have any things to clarify. Okay, thank you. That is from me.
Great. Thank you very much, Henry. Thank you so very much for the great presentation and both the case studies. So like Henry said, now is the time for question and answer. And we have reserved the next 20 minutes for question and answer. So please feel free to ask any question by unmuting yourself, or also just write your question in the chat, whatever works best for you. I believe we actually had a few questions. There was someone that asked a question about what program to use instead of Python.
Oh, okay. In the first one, I think, yeah, my projects here. Okay, so actually, I only use two main software here. The first one is the process simulation software. I use the Unisim design. Why I use Unisim? Because the license that I have currently at that time is the Unisim license, and then the modeling and the optimization, I use the Python. The modeling, I use TensorFlow library, and the optimization, I use SciPy library. So the TensorFlow library is used for the neural network. This one, the neural network is used to build the complex model. I will use the neural network to build the empirical equations that will be optimized in the SciPy model library. So I think that is
perfect. Thank you, Henry.
okay.
So I believe we have a question. May I know how to apply ODE in optimization with the help of Matlab?
Okay, yeah, really interesting one. Yeah, one of the interesting application in Matlab that cannot be used, I think, in GAMS, because GAMS cannot do the ODE as well as Microsoft Excel, and it is quite hard to do the ODE in Excel. You should build your own spreadsheet, but GAMS cannot do ODE at all. If I'm not mistaken, the one if you want to do ODE optimization, I think one and only is the programming, either is Python or Matlab. So you can combine the admin search or admin con, the subroutines with the OD. Yeah, maybe you know that there is the routines OD, maybe OD 45, and then the objective function that you want to be integrated. Yeah. So if you have the function in the integral form, you should convert it first into the normal one. For example, maybe I can write a bit here. For example, if you have an equation dt per dx equal to something, maybe x squared, let's say, you should integrate this first before you optimize. And you can do that with the ODE routine here, ODE 45 at function x0, for example. Yeah, so before you optimize in the Matlab, you should return it. This one, you should change this this problem into, wait a minute, this one into t as the function of x. Okay, Matlab cannot optimize a function in the form of derivative. You should change that into this kind of function first. I hope that clear for you.
Perfect. Thank you, Henry. Another question was, where can we find more study cases like these solved in Excel or Python?
Sorry?
Where can we find more study cases like these, either solved in Excel or Python?
More case studies. This case studies that I used actually was adopted from the book here. Yeah. This one. This book contains a lot of case studies. Maybe I will share with you the book. Wait a minute. I will share my screen. I really recommend you guys to read that book if you have any time, because the book is really good for me. Wait a minute. Okay, this one. Okay, I will share my screen again. Okay, this one. So you can see that Humboldt have the optimization case in every sector, the heat transfer, separation processes, fluid flow, chemical reactor design. So you can take cases from here as your practice to do optimization. This is a really good book for you. Okay, I think that's how I get my case study.
Perfect. Thank you, Henry. The next question someone asked is GAMS an open source software?
I think it is not an open source because I get this from my university. It requires a license. Yeah.
Exactly. What is the iteration constant K in optimization? And why is our iteration constant 2 or 3 at the start of optimization?
Sorry, can Muzamil Abbas told me where is the K constant in the optimization? In what slide or in where that you find that? Because I didn't feel I put it here. Yeah. Maybe the other question first before the response.
We can take the second one. Yeah, we can take the second one instead. Question asked by Gupta. Can we perform optimization of nonlinear equations like thermal conductivity models of nanofluids using Origin Pro software?
Origin Pro. Actually, I never studied about that software, Origin Pro. So I'm not sure that if it is able or not to do the optimization in that software. But if you want to do a non-linear equations, actually the 3 software that I present today able to do that. Yeah, I'm sorry, but I never used the Origin Pro software.
Thank you, Henry. Question asked by Akash. What makes GAMS so different from Matlab?
Okay, this is a really interesting one because in Matlab, actually, optimization is only a part of what Matlab can do. You can see here that there are so many applications that we can use in Matlab. Optimization is only a little tiny part of Matlab, so we can say that this is not the Matlab specialty, but GAMS is the space. It can do only one thing: optimization. We cannot do codes, the normal one in GAMS. So what make GAMS in some case better than Matlab? First, you can see just now from the second case studies, it is more simple to do optimization here. If you compare to the Matlab in the second one, you can see this is more complex to define. But in GAMS, we can do it is here. And the second one is when you are faced with a more complex optimization problems, GAMS is the best one for that, because GAMS contains a lot of solvers that can be used for optimization. If you want to see one of the the problems here, I can do heat exchanger matching with GAMS. You can see this is more complex to be done. And if you do this at Matlab, maybe Matlab cannot do this iteration because this is a really complex optimization. Yeah.
Perfect. Thank you, Henry. The next question asked by Shamo. Sir, if I want to find optimum temperature and pressure for a reaction, how can I model and optimize?
Okay. Actually, I ever did this before. So my suggestions is, if you're doing it at the simulation, you can do sensitivity analysis by changing the temperature and pressure of the reaction. You can use the simple model, the simple reactor model in the simulation. You do a sensitivity analysis, and then you send the sensitivity analysis to the Excel or to the Matlab, and you can graph the plot, the Matlab plot at the result of the sensitivity plot, and you can find the optimum one. So I think that you cannot do that by codes, but you can do that with visually. Yeah.
Perfect. Thank you. And Muzammil, we haven't heard back about the K. You can just write that in the chat, but we haven't heard back from him. Maybe and regarding, sorry, go ahead.
Okay, so maybe I will show my work about the pressure and temperature. Yeah, for better this. Wait a minute. Wait a minute. Okay. Okay, this one. This one, I will share my screen now. Okay. Okay, this is one of my work about the methanol reaction. I do the optimization with the free variables is the pressure and the temperature. You can see here, you should plot this as a 3D models rather than 2D models, because if you plot this as a 2D models, you cannot get any insight. I use the surf in the Matlab, the surf, using surf syntax in the Matlab to build these 3D models. So from this picture, you can see and you can determine your optimum value.
Hello, sir. Actually,
yeah,
I have asked that question of the reactor, but I had a simple doubt that how can we integrate the cost part into the modeling? Like as you have shown the picture that by increasing pressure and temperature, your selectivity is increasing, but we have to keep in mind the cost also. So how to integrate the cost into that particular optimization factors?
Okay. Yeah, if you want to integrate the cost to this model, you cannot build this as 3D models because it requires another access. So it is like a 5D or 4D models with more variables to be done. So that is what I do in the wait. I'm sharing my PowerPoint now.
Yes, you are.
Okay. Yeah, this one, I have two models to be optimized. The first one is the cost model, and the second one is the reaction model. So this is more likely the same like your problem. There are two models here that I want to optimize: the cost model and the product model. So I didn't integrate this, but I have two models here. Yeah, because if you want to integrate that, you should found something like this. Wait a minute, like the first case studies, you have actually two models, right? The heat that we can save and the heat and the income, the cost. Yeah, we have two. The first is the heat and the second one is the cost. It is a different variables with a different units. The one is dollar, the second one is kilojoule per hour. So we cannot combine this model. But if you have like this parameter that can make the kilojoule per hour into the dollars, you can integrate these two models. I hope that is clear for you.
Yes, sir. so we can optimize two models parallel, in short. Okay.
Yeah,
I got that. Thank you.
Perfect. Thank you. Well, there is another question, Henry, from Miguel. Can you give an example of uncertainties in the processes and how the uncertainties should be considered in the optimization problems?
Okay, I think the uncertainties in the process is as simple as if you are working in the upstream of the oil and gas, while you are uncertainties with what is coming from the well, from the gas well, or from the oil well. It is one of the uncertainty. And if you have like the history data of your plant, you can see some variables is doing oscillation, so it is not stagnant in one point. It is what I mean by uncertainty. And how to eliminate that? You can do some scenarios. For example, you do the minimum scenarios, the maximum scenarios, and the average scenarios. So you can do 3 optimization with three different parameters. Okay.
Mm-hmm.
I hope that is clear. Yeah.
Perfect. Thank you, Henry. Then we have heard back from Zomo. He's talking about the optimization methods like Hooke's-Jeeves method, where the iteration constant is taken to be 2 or 3. Because we start, like my question is, his question is, why do we take the K value to be 2 or 3? Because we should start from K is equal to 1.
Yeah. Wow. Actually, I never used the Hooke-Jeeves method for optimization. I know what do you mean now by K value is equal to 1. You're right that actually in most model we should start it from 1. Yeah, I will do some research. I just know it from you that the K value is start from 2 or 3. Yeah, I will do some research because I never used this method. I'm sorry, Muzamil Abbas.
Thank you, Henry. Thank you.
But in most problem, it will start from 1.
Mm-hmm.
Okay, yeah, you can continue.
The next one is asked by El Hassan. How can you compare Unisim with HYSYS? And what are your impressions about Unisim of Honeywell?
Okay, yeah, actually this is not about optimization, but it's okay, but I will still answer the question. For me, it is not too much different between Unisim and HYSYS, but in Unisim you have more unit operations. It is not more, but there's a different unit. For example, it's gasifier. If you are working with gasifier, you can find it at Unisim, but you cannot find it on HYSYS. But some of HYSYS unit operation also cannot be found in the Unisim. So yeah, it is up to your projects. What do you need? If you need some gasifier, then you go to Unisim, and if you go with the oil and gas projects, for example, you can go to the HYSYS. Okay.
Perfect. Thank you, Henry. Then I believe the very last question is that which is the best recommended method for optimization from your study? Okay.
Actually, this slide. Wait a minute. This is from my experience. For me, if I use the indirect method, it is more faster to converge than the direct method. But in some case, that it can have a serious problem. But my suggestion, when you're doing the optimization, you should start in the indirect method. If you encounter problems, you can do another guess, or you can change the method by direct method. And the indirect method, if it is the if you are working with the nonlinear, I'm really like to use SQP, especially if you are working with the simulation process. If the linear programming, simplex is really good by using fmin search in the Matlab. I think every case it has the different one, but there is what I mainly use for optimization.
Thank you. We still have a few minutes left, so does anyone have any other questions? Feel free to ask them in the chat. Oh, there's a question from Andrew. Can I use only Excel for optimization?
Okay. Yeah. for me, if you are using only Excel, it might be, but from our case study, I can still consider this as a simple optimization. So if you have a simple models, yeah, you can do it on Microsoft Excel. But when you come to the more complex one, I don't think that Microsoft Excel is suitable, because when I preparing this workshop, I ever encountered an error that the Microsoft Excel cannot find an optimum value. So yeah, that is one of my story when preparing this workshop. When I search for some optimized value, the Excel is error, so I should change my problem, the value of the problem. Yeah, the parameters should I change, so the Microsoft Excel can start again. Yeah,
Exactly.
that is based on my experience.
Exactly. Yeah. Please, can you share free optimization software names?
Yeah, actually, these are the three softwares that I ever use for optimizations. I'm really sorry that I never try to use any open source software, because my university have the license for this software. I can get this for free. Yeah, so I am sorry that I never used the open source one.
Great. Are there any more questions? And people ask about the sharing of the material and the recording. We will share the recording with each and every attendant. So, and we will also upload the video on our YouTube channel. So it will be available to you even after the workshop. And even after the work, go ahead, Henry.
Yeah, the files I also will share it to Humzaa, so Humzaa can share it to everyone. Yeah.
Perfect.
The Matlab files, the game files, and the Excel files, I will share it.
Exactly. Thank you, Henry. And also just a quick comment, because when you go to our website and you go to our webinar area, you should have the link to the YouTube channel. And if you have any questions after the workshop, when you're doing it yourself, we have a forum on our website as well. So please feel free to go there and raise any question that you may have, because then, because the other visitors can also get benefit from the questions that you may raise. So we have another question from Alex. What is the most complex model you have solved working for a company?
Okay, so actually this project is not for a company, but I can say that this project is one of the most complex one. Why? Because if we are working with the complex process, the end-to-end process from the feed stream to the products, we cannot build models, the empirical models from this particular process. So yeah, it is really impossible that we can build something like this. Okay, this one, yeah, we cannot use this because if we are working with the simulations, it has thousands of variables, of constraints. It's really hard. So my approach is I use the machine learning here. It is quite new for me actually to use the machine learning in the chemical engineering projects, but actually this come out as one of my most interesting projects, because really love to do this optimization. And what makes this also as a complex process, I have many objectives here. The first one is the products. I should make the products upper than one value, like more than 40 kilogram per day, for example. The second one, I should minimize the cost. And the third one, I should minimize the emission. Okay, so I have three objectives that I should solve by using optimization. So it is quite complex for me. I don't do this by myself. Of course, the optimization part, because it requires machine learning, I do it with others. Yeah, it is really interesting.
Perfect. Thank you. Then I guess we won't be able to take any more questions due to the time. So once again, well, thank you so very much, Henry, for the wonderful presentation and also for sharing all the and answering all the questions. And thank you to everyone for attending the webinar today and also for asking all these questions. Now, for the next steps, all of the attendants, you all will receive a certificate, a signed certificate from me and Henry to show that you have signed up, and you will receive all of the materials and also the recording of the webinar. And like I said, the recording will be available on our YouTube channel as well, so you can always go and watch it there. We highly suggest that you do all the case study that we discussed here by yourself as well, so you can get your hands-on experience as well. If you guys may have any questions, which probably you might have, then you can always, like I said, go to our website and we have a forum and raise a question, and so that any visitor that visits it, they can have the same. They can also share the knowledge that's being shared there. Great. Do you have anything to say, Henry?
Okay. Yeah. Thank you very much for your attendance. This is a really interesting sessions to share with you guys. As I say that we are still dealing with the simple models, but I think me and Humzaa already set for the next session. We will do a more interesting optimization using a more complex process, and we will use the process simulation to do optimization, and it will be more interesting than this session, because yeah, we will do more optimization on that. Okay, I hope this session will be useful for you guys. Thank you.
Thank you, Henry. And thank you, everyone. And like Henry said, also do remember to go to our website and become a member so that you can stay updated on our upcoming webinars as well. And then once again, thank you for making time on Saturday to come and listen to the presentation. And I hope you all have a lovely weekend and have a great day ahead. Thank you. Bye-bye.